Hello, everybody. I'm Saurabh. I work with HP Cloud database as a service team. We basically deploy OpenStack Trove project, and we use SaltStack to run the service. So in today's talk, I'm going to talk about operations and support aspects of SaltStack, like what all we do in order to leverage our operations and support team and provide a secured environment so that basically whatever instances we have or pillar data we have or the credentials we have or any secured or sensitive data, how we protect it. At the same time, how we make it easy for our operations support team to basically go there and debug issues or do day-to-day daily operations with respect to providing upgrades or patchings or basically deploying new stuff. So this is basically what I'm going to go over. I'll give you a quick overview of OpenStack Trove project, then a high-level overview of our Salt environment. We'll go over what type of automation we have. We'll slightly, for a bit, we'll talk about what is different in terms of operations with SaltStack as to what exactly changes for an operations team. We'll touch base on Salt module states and then some issues that we are trying to tackle right now. So talking about OpenStack Trove, OpenStack Trove is OpenStack's database as a service project. So out of the box, it provides support for MySQL. It's a REST API service using which you can create managed databases. Something similar to Amazon RDS, if you might have used it. So it provides support for MySQL database out of the box. And right now there are basically HP, Rackspace, Mirantis, and other few companies who are working on this project. So this is a high-level architecture of OpenStack Trove. Basically what we have is we have 3 different Trove services which internally talk to a messaging queue, infrastructure database, and then talk to OpenStack Nova, where they go and provision instances on which MySQL actually runs. So for database as a service, we manage everything on the left-hand side of this diagram and also all these MySQL instances. So using Salt, basically what the deployment automation that we have is primarily for the left-hand side of this architecture diagram, wherein we deploy the whole architecture using SaltStack, provision it, install services, upgrades, and everything. The right-hand side is actual MySQL instances. So the reason we primarily use SaltStack is we wanted a way of managing all these instances without doing an SSH onto them. Because this is like a customer's data that's running on these instances, and there is no way that we would go in on these machines or basically log in on these and do something. So in order to provide operational support on these instances is where we basically started using SaltStack. So going over quick Salt environment that we have. So we have a master, Salt master running for every deployment that we have, like every deployment in every data center, or even for our staging, production, pre-production, all type of deployments have a separate Salt master setup. We use multi-master setup. This obviously provides HA in case basically one of the master goes down, because we are all running in the virtual environment. we try to manage salt master just like any other minion in the system. So what we do is we install salt minion on the master itself and make it part of, or basically add it to the master so that we can write states, modules, pillar for the master and basically manage everything on the master just like any other salt minion. We maintain our states, pillars, everything in a separate directory. Everything in a separate repository. The idea behind this is for every production environment or for every staging or every pre-prod, basically states are identical. They don't change. What change is the pillar. So basically IP addresses, credentials, or maybe configuration parameters. So what we do is we maintain states and pillar in a separate repository. States are common across all the deployments, similar type of deployments, obviously. And pillar is maintained per environment. So basically, if there are 2 prod environments, there will be 2 different pillar data for that environment, but states are going to be the same. So in the earlier diagram, I showed you that all the MySQL instances that gets created on the right-hand side are managed through Salt. So every MySQL instance becomes a minion in our system. So that is managed through Salt. And we have an automated way of accepting and deleting those keys on the Salt master. So basically, when an instance comes up, there is a script that generates a unique ID depending on a lot of different type of information that's available on that VM or on that instance, including ID, some hypervisor information, and basically generates a unique ID. So that guarantees us that there won't be any conflict on the Salt master. So there is a script that what it does is it watches for all the create events. If there is a create event and we see a key for that create event, then we accept it. Otherwise, we don't. And then similarly, in case of delete, we delete those keys. So this is like a high-level overview of the Salt environment that we have. What we do is, as I said, primary reason of using SaltStack is so that we can provide the support or operation support on the customer instances. Operational support meaning upgrade the Trove packages, or maybe upgrade the MySQL if that's needed, or basically if there are any issues that they are facing. So for that, we use SaltStack, and using SaltStack, we can basically manage that without manage the instance without logging onto the instance itself. Yeah. Sorry? I'll get to that. I'll get to that in next slides. So as he validly raised the question that although with SaltStack we disabled SSH, but the primary concern is that we do not want to allow anybody to be able to basically play with that VM unless that's like a legitimate thing that is being done, which is upgrading a package or upgrading a config parameter. So this is basically what I want to talk about is what is it different in terms of operations with SaltStack. So whenever we are dealing with SaltStack, access to the Salt master is a must thing. Like, I mean, without logging onto the Salt master, you cannot pretty much do anything. When you log onto the Salt master, that's where your pillar data is usually located. Once you get onto the Salt master, the whole infrastructure is available to you. Like every minion is basically available on the Salt master. I mean, you can deal with every minion from the Salt master. You should be able to audit individual users' Salt commands from Salt master, so that basically if you're not using SaltStack, you would do this by looking at your, I think, WTB file in varlog that will tell you what exactly user did and stuff like that. But with SaltStack, you should be able to figure out what type of salt commands user executed and audit the command execution, as in whenever a specific command was executed, what all happened with that command, what changes it did to the systems. So talking about the pillar data, this is, again, specific to our use case. Somebody might go and use pillar, external pillar, and pull that data from database or somewhere else. But if you have data residing on the salt master, you would definitely need correct ACLs to protect the pillar data. And basically, you should consider encrypting that pillar data so that basically an ops guy, when logs onto the salt master, he has only limited access, wherein he cannot really look at your pillar data, but still he can do operations like if, let's say, your service is down, he can probably restart it, or at least can figure out what exactly is wrong with the system. So I will quickly show you. Okay, when I talk about access to pillar, this is basically a demo setup that I have. So in this, I have pillar and state. Basically, all these directories will have pillar data and states. So as you can see, so what we do is we run salt master under a specific user. We don't run it as root. All the minions definitely run as root, but not the master. And basically, all the pillar and state data is owned by that user under which the master is running. So salt master, when it's running, it will have access to that data. But when a regular user or an ops user logs in onto the system, he won't really have any access to that data. So for that, what we do is we have a group for salt, and our salt master is also running under the same user and group. All these pillar and state directories are owned by salt, and admin users will have basically membership of the salt group, but ops won't really have it. So an admin user can query or look at the pillar data or states data, but ops user will not have access to it. Right.
Sorry, yes. An ops user should be able to run salt commands.
Right.
So when you be able to access the code data from that?
Right. I'll get to that in next few slides. So I have two questions to answer. One is yours and one is other. So I have it in next slide, so I'll just get to it. So again, idea is that basically an ops user, the sensitive data or pillar data should be protected so that everybody who gets onto the system does not necessarily need to know what the credentials are, does not necessarily need to know what the IP addresses are and stuff like that. So this is one way of basically just like adding correct ACLs, but this is again not 100% foolproof way of protecting it. Other option is basically adding some encryption on the pillar. So we have two level of encryptions that we currently are using. One is when we put that data in the repository, that's encrypted. On the salt master, basically again, some of the data is like some sensitive data is encrypted as well. So I'll show you here. I'm sorry. Like, okay, so this is a sample pillar file for RabbitMQ. This is the first one is an encrypted pillar value for the passwords. The second one has it in the plain text. So what we use is an external pillar script, and what that script does is it looks at a pillar in a particular pattern and basically reads the value, and before that pillar is given to any state file or any state, it updates that pillar with an unencrypted string or decrypted string, sorry. So I want to quickly show you how we do that.
Is that shared anywhere?
I just modified it right now, and I'll put it on the GitHub where all these configuration and scripts are in the same thing.
Can you scroll that up?
On this one?
The other way. So they can't see the bottom.
Oh. Okay, hang on.
Clear screen.
So here I have two RabbitMQ nodes added. One of them is using an encrypted pillar and other one is not. So I'll show you. So right now, even on the encrypted RabbitMQ, you can see that these values are, or rather these passwords are in encrypted format. Right. Right. So in this external pillar module, what is happening is there is this ext pillar method. What it does is it looks at your ID, minion ID, and it then looks at the top file. And basically, if the top file has a specific pattern in which a pillar is specified, for now, I'm using a very simple thing wherein it says ENC. If it finds a ENC in the name, it considers that it's an encrypted pillar file. And it looks at that data and basically try to provide you with an unencrypted form of it. Which I don't know why it's not doing it right now because I have it. Sudo salt must. I don't know. It's supposed to give you an unencrypted string here. I think I messed up something while preparing this. But I will put this on the GitHub where all these configuration files are, and it's pretty simple. It's just doing a very dumb thing right now, wherein it basically takes this string as your cipher and try to basically encrypt it using this. So what I'm saying is that pillar is a very sensitive information, and basically everything that we can do to protect it is something that we should consider. Come on. No? No, on the master. On the master. So what happens is basically when you say state.highState, let's say, or you say pillar.items, Salt tries to compile the pillar data for it. Every time it's trying to compile and pillar data, it will call every external pillar that you have configured. And in that external pillar, what you have is you will have to basically return a dictionary in that pillar or in that method. And that dictionary basically can contain any additional pillar, or it can have a value for the existing pillar, in which case the existing values will get updated. Right? So right now, as we saw that there was an encrypted string for the key, but if basically an external pillar provides a new value, which is a decrypted string, then that value will be updated, and that's what your minion will see. So even though you are able to encrypt the pillar, when the pillar is flowing from, or basically pillar is not encrypted in cache, either on minion or master. Basically, it's just plain text, because okay. So just like protecting the pillar is important, at the same time protecting your infrastructure is also important, because when somebody is on the Salt master, every node in the infrastructure is reachable from the Salt master. So what will you do basically in order to protect it? You cannot really protect right now from Salt master. You cannot really protect an access to a particular minion, but what you can protect is what type of action a user can do on that minion. So here I have a config. So this is my master config right now, and I have two users created on the system. One is Saurabh and another one is Saurabh Ops. So obviously Saurabh is the admin user and Saurabh Ops is an operational user. So as you can see, what I've done is I've granted every type of module to Saurabh, because he can do anything on the from the Salt master. But Saurabh Ops can only do like test.ping or RabbitMQ. So just as an example here, right now I'm logged in as Saurabh here, and I can do pillar.items, right? I can simply execute this, or I can do state.highState. But here I'm logged in as Saurabh Ops, and here it won't let me execute those commands at all, whatever I have not specified in this list. So this is another very useful feature or very useful configuration that one should use. In some of the talks earlier, there was a basically mention of client Acl Blacklist. This is another very good feature wherein it allows you to basically say that, just like the earlier one said that whitelist the modules that a particular user can run, this another one allows you to specify an blacklist, wherein you can say that a particular user is not at all allowed to run any command, or some specific commands are not at all allowed to run by anybody. Like I've disabled command here. I honestly feel that there are many more modules out there which, if granted access to an ops user or basically somebody who's doing operations, it stands a very good chance of creating problems. So obviously, I mean, you would need some of the modules or some of the capabilities to provide support, but we need to basically case by case identify what is something that we want to hide or control. So these are some of the modules which are fairly tricky if given access can cause a lot of issues. So we usually disable most of the modules for an ops user or support personnel. And this is, again, like going through a lot of iterations. as I talked about, basically using Salt, a user can execute many commands, and you should be in a position to identify that if a particular command caused an issue, when it was executed, by whom it was executed, and with what parameters, if possible. Right now, I don't think we can identify what parameters it was executed as, but Salt does have support for identifying this information, as in who executed that command, what command was that, and on which minion it was executed. Yes, sir.
Is that audit available on each minion, or is that just available on the?
It's available on the master.
On the master?
Yes. I would show you here. Okay. So in order to get to that, basically there is a configuration change, or not a change as such. You can still basically get this using log level debug, but the debug logs are too much. So basically if you set it to info, this is what you will see in your logs. Okay, so let's say I do blur.items. So here, it shows me that user was Saurabh. Then it shows me that it was executed on this, or sorry. It was executed on this minion. No. Yeah, it was executed on this minion here. So it is a little tricky in order to be able to track that information, because the way you will track it is right now it is at two different log lines. So the first one says that this guy executed the command, and it says that this is the job ID. And the second one says that this job ID was executed on this minion. So it is in two different lines, but it's still like usable. Did it print? Yeah, I don't know what changed. I'll fix it, but and I'll try to see if I can show it in the later part of the talk. So yeah, I mean, this is another very useful information that we try to log, audit, and have an automated way of basically identifying if there is something going wrong or somebody is doing something wrong.
I just do a follow-up. Not to belabor the point. On the minion, the minion process is executing some minion user whatever. Is the user that executes the action on the master actually passed to the minion? Would I see that in the minion?
No, no. That information is only available on the master. You won't see that on the minion. So on minion, you cannot identify that this particular command should be executed by user X and not by user Y. That is something you will have to configure on the master and control it from the master, right? Again, every job that gets executed in the whole Salt framework will get recorded in the job management framework of Salt, and you can query that data. Although basically it's not very user-friendly at this time to be able to query on to find out what all jobs got executed on a particular minion, or on how many minions high state was executed in last half an hour, stuff like that. So basically try to use returners, and that's basically very useful feature wherein it logs all the data for a particular command execution into a database, and that's something very useful to be able to go back and query some stuff. As I said, we use Salt itself to manage the Salt master, because Salt master has a lot of configuration, like stuff that I showed you right now, permissions, repositories. We use multiple Salt masters, so syncing data between two masters. So what we do is we use Salt itself to manage the master. We install a Salt minion on the master and add it to both the both of our master, and basically we are able to write states to configure the master. So we control things like user accounts, permissions on the directories, files, Salt master configuration for controlling access to commands and users and stuff like that. And that's very useful. Show you here. Sorry. Right. So here, the last one is actually the minion of this whole same machine. Sorry. And I can query for it saying that give me all the pillars or stuff like that. So this is very useful, and basically stuff that we do with this is, I think I talked about it, user management, adding or deleting user accounts, and permissions, configurations, packages that we want on this master. So we'll go next. So salt states. Basically, so all this that we talked about right now, most of this is automated using Salt master, that Salt minion that we install on the master. Everything is controlled using those states of the master. So basically, even if somebody goes and modifies something manually, in next 15 minutes or next half an hour, that will be perfected or corrected, because the state.highState would go and modify or bring the master into a particular state so that nobody can really mess up with it again. So salt states. Now, basically, one of the things that we found when we started doing operations is initially we wrote a lot of states, a huge basically state.sls or SLS file, and basically we tried to do everything in that. And what we figured is when we are doing operations, we want small actions like updating maybe user credentials or installing packages, or maybe updating something on the for security packages on the system. So what we figured is that basically if we try to separate actions into groups in your state file, it is very useful for operations, because then basically nobody has to go and do state.highState every time. So let's say you want to go and change credentials. You don't really want to do state.highState, which will also try to do something for the packages, configuration files, and whatnot. So what we basically started doing is we are separating everything into a group of actions. So group of action meaning that if, let's say, I'm changing credentials, yes, if I change credentials, I definitely want to update the configuration file, but I don't want to do anything for the packages. So separating actions into separate states basically is a very good validation for the operations. So this is an example that basically a state can have package installation, user creation, configuration management, or update of the security packages or other system level stuff. But when you're separating these, it's very important to maintain the dependencies. So let's say that you separated user credentials and configuration file management. At the same time, you want to make sure that when your configuration file is updated, the service gets restarted. So maintaining the necessary dependency is a must thing to do. again, if the benefit is that if, let's say, you separate package installation from user management, every time you want to update a package, you won't touch base or touch anything for the users. Right. The next thing I want to talk about is whenever we write states, we try to basically account for the user errors. Like simple thing would be that basically when I'm writing a state for the salt master, I will make sure that that state gets executed on the master itself. So I'll basically check, maybe as simple as check the ID, saying that whether this ID matches or it has a name or string called as master in it. There are many simple checks that you can do, and what this will help in is basically it will avoid running a state on a wrong target. So let's say I have a state for user creation for SaltMaster. I want to make sure that those users always get created on master and nowhere else, like not on any of my infrastructure machines. So accounting for user actions or user errors is basically something that you can do. I'll quickly show you here if I have a state. Sorry. I don't have it here, but I mean, it can be very simple, as in checking for the ID and making sure that it has a particular string in it. The next thing that I wanted to talk about was modules. So this is where really we add some automation capabilities to our operations and support framework. So what we do is we definitely use modules which are in Salt, and they are really powerful. There's no doubt about it. But what we identified was whenever we are doing operations or support, let's say, okay, my RabbitMQ cluster is broken. There are a whole bunch of things that we do in order to fix things. And basically, all those actions are most of the time on one machine. There are a set of actions that we do, like for a particular issue to fix or error to fix. And what we do is we write modules for these kind of actions. So let's say we have modules for maybe bringing up a Galera node in a bootstrap state, saying that if my cluster is broken, I'll basically bootstrap it as a single node or stuff like that. So extending modules in Salt is very simple. And these are basically the cases where we try to write modules of our own. So if, let's say, there is a module which is useful, but it has a potential of causing, if given access to a wrong user set, it has a possibility of causing harms to the system. So we go and wrap it up with some more authentication or some more strict permissions so that it's not as harmful as it could be. Another interesting thing about modules is that when you're writing your custom modules, you will be able to leverage whatever is there inside Salt. So what we usually do is, let's say, I want to cat a file, cat a log file, right? I don't want to give command.run access to somebody, and I don't want to give file.cat or file.cp permissions. So I would just go and write a wrapper which internally goes and calls maybe command.run to cat something. So basically, wherever we see that a user is executing multiple set of commands to get some action done, that's where we go and write a module. And This is, we definitely go and write a module for is if, let's say, a user needs access to the pillar data in order to do a particular action. We definitely go and wrap it up in a module so that module gets an access to the pillar and basically user does not need to know what the pillar value is. So this is pretty much I wanted to talk about. I don't know if did I answer your questions? I did. Yep. So I'll be putting all this configurations that I used on the GitHub, get access to it. Sure. Right. So as I said, basically, there are two ways we do that. One is whenever we are spinning up an infrastructure node, we make sure that when the node is getting booted up or getting created, we all do this on OpenStack Nova, by the way. So whenever a node is getting created, we provide it with a user data script, which goes and installs a minion on it with a correct target, which is the IP of the salt master or the host name of the salt master. For the customer instances, it's something similar wherein that is baked inside the instance or baked inside the image. And that IP is basically managed on the fly using the OpenStack. Like you have an option of specifying some more files when you boot the instance, and it grabs the IP or correct target from those files. It does happen. So, so what happens is, I've seen this like in early days when we were like trying to stand this up. And what used to happen is maybe there was some networking change. So all of this is happening on the virtual machines. Virtual machines are running on some host. If let's say there is some networking change on that host, let's say somebody restarts IP tables, or there is an corrupt IP tables, right? So my VM is fine, but there is some change in the networking which Salt process did not like, and it died. And so we do all this on Ubuntu, and on Ubuntu package, Salt has an upstart script. And but in that upstart script, there is a respawn which is commented out, saying that this is very risky. So that process won't start on its own. So what we have is we have watchdogs, which would basically try to monitor this, and if it dies, it will restart it. But yeah, I mean, it does die. We've seen it. Although it's not very frequent, honestly. It's fairly reliable. Yeah.
Just to get a sense of scale of the user management issue here, how big is the ops team?
30 people, 40 people. No, I mean, it's not honestly, it's not the problem with the number of people. It's the problem with basically somebody who is in the ops team or in the support team who identifies the problem and have capability of fixing it. Whereas somebody who really has the capability of fixing it, there is a difference, right? I mean, so I personally have a belief that if I know something that is, oh, I'm sorry, I did not realize that. If I know what the problem is, and if I know what the solution is, I will go and apply it. But if I have a lot of information, and even if I don't know what the solution is, I will try to go and try to figure it out and not really do it the right way, right? So what we are trying to do is we are trying to make sure that whoever has access to the system, and if they are really concerned about debugging it or identifying what the problem is. They should only identify and let somebody who is able to fix it handle it after that. Maybe, sort of like, I mean, not really a peer review for fixing a problem, but really getting it fixed from somebody who really wants to fix it or who is capable of fixing it. And the reason basically we take this so seriously is because all the data, all the MySQL instances that we run are basically customer data. So we want to make sure that there is no way somebody can get in there and screw with it. Like, I mean, that's like the last thing that should happen. And yeah.
So that number of 30 that you quoted is just for the database team?
No.
That's the whole.
Oh no, that's not really the operations team as such. That's probably the support team, I would say. Yeah, operations is like for database very small, maybe 5, 6. We are all DevOps, by the way. I mean, hardly we have any dedicated operations. But yeah, we do have a dedicated support team, and they are like 24/7. We are not 24/7. I mean, everybody is not awake all the time, right? So this guy is, by the way. Thank you, everybody.